Hi, welcome to our next Level 2 Statistics Inference video, our last one, and we're going to focus on our conclusion. Now, the conclusion is an important part of the process, and we must link it back to our problem. The question that we raised in our problem and our prediction, we're all going to link it back. So in our conclusion, we're going to do the following. We're going to answer the question you've posed in your problem. We're going to link back to your prediction. We're going to discuss any reflections on the sampling process and how accurate you believe the inference is. This includes a mention of this term called sampling variability. And we're also going to discuss any further areas of investigation that have come up due to the findings of this investigation. In other words, what can we move on to and explore next? So let's answer the question. This is the question we raised in one of our first videos about the median time it takes to run a marathon for males compared to the median time it takes to run a marathon for females. And here's probably how I would answer it. I can make the call that the median time it takes to run a marathon for males tends to be less than the median time it takes to run a marathon for females within the population data set of 200 marathon runners in the Auckland Marathon in June of 2009. Notice something really important. I've almost copied the question down in my answer, word for word. It's vital that you answer the exact question you've raised about the median time it takes to run a marathon for males and females. Right, the other thing we need to do is to link back to our predictions. So a very quick comment about your prediction and write up what's happened after your inference. Right, let's get on to the sampling variability. We know we use a sample from a given population to make an inference about the population. We're going to use this term sampling variability. This refers to the fact that the statistical information from a sample will vary as random sampling is repeated. In other words, your statistics that you get from your sample, including your informal confidence intervals, will vary every time you take a sample. Now, a very closely related term is a term called sampling error. An error in sampling isn't actually an error or a mistake. It's just a measure of how much the value differs from the true value, the population value. So say the true height of a population is 150 centimeters, and you took a sample and got a height of 154. There's a 4 centimeter difference, and we call it an error. It's not an error, it's just a difference. Every time you take a sample, that error or difference is going to change, and we call this sampling variability. Now, very quick recap on these informal confidence intervals. Remember the formula we used? And let's go through a quick example once again using an interquartile range of 20 and a sample size of 50. When we do this, we plug it in and we get an informal confidence interval of plus or minus 4.24. However, if we increase the sample size, because there's some people think the larger the sample size, the better it's going to be. If we increase the sample size to maybe 100, what that does to our informal confidence interval is it reduces down to just plus or minus 3. It actually reduces the confidence interval. So a larger sample size will likely result in a sample that's more representative of the population, but will also result in a smaller confidence interval because we're more confident the population median will be in between a smaller range. Right, so you need to reflect on your sampling process, discuss how reliable you believe the sampling process was, and how representative the sample should be given to the population. What if by some luck you'd picked a whole lot of professional male marathon runners in our sample of 50 and a whole lot of female runners that just like to run marathons as a bit of a hobby or for fun? Right, well, our final part of our conclusion is, are there any further areas of investigation? You might decide to comment on some further areas of investigation that's come up based on your findings. For example, we've just figured out there is a difference between the population medians of males and females in a marathon. Does this apply to long distance cycling and swimming too? Okay, well that's us for our statistical inference. All the best in your write-up and good luck to you